Hi and welcome. So we're going to look at a very short video on how to subtract two different binary numbers. So we should know by now that the binary number system consists, so the binary number system consists of zeros and ones. And we need to be able to subtract any two different binary numbers and yield an appropriate result. So if I was to look at some of the rules first of all, so we can say that we have an initial set of rules that we can use, and these are rules for subtraction. Okay, and the rules are quite simple. So we have 0 minus 0 is equal to 0, 1 minus 0 is equal to 1, 1 minus 1 is equal to 0, and 0 minus 1 is equal to 1 only if we can borrow. And look, we'll explain this now in a minute. Okay, so only if we can borrow. So these are essentially all the rules we have. Okay, right. So once we understand these rules, it's relatively straightforward. So let's take a few very simple examples. Okay, so the very first one what we look at is, if we take the example of the number 7. So we say 7, which is equal to 111 base 2, and the number 2, which is equal to 10 base 2. Well then, if we were to subtract these two numbers, so I know obviously that if we have 7 base 10 minus 2 base 10, well, I should be getting the number 5. Okay, so if we consider the rules just above, well, if we say, well, 1 minus 0, okay, so this is the very first one we have here is 1 minus 0, which is actually looking at this particular rule that we have here. So we say 1 minus 0, well then that's going to be equal to 1. 1 minus 1 is equal to 0. And then 1 minus, and we can add in the 0 here, but 1 minus 0 is going to be 1. So we can say that 111 minus 010 is equal to 101 base 2. So which should be the number 5. But let's just expand this out, right? So, and if we were to look at this as a conversion, so we want to convert the binary into decimal. So we would simply take down this number here. We say 101. We would identify the least significant digit, write a 0 above it, and then count or annotate from right to left 1, 2. So now we expand out this number. We say 1 multiplied by 2 to the power of 2 plus 0 multiplied by 2 to the 1 plus 1 multiplied by 2 to the power of 0. So this is how we convert from a binary number into a decimal. It's called a position value expansion, and we use the base of the number and the index location of each digit, and we take the number, we multiply it by the base of binary raised to the power of the index. So we have 2 to the power of 2 is 4, multiplied by 1 gives us a 4, 2 to the 1 gives us 2, multiplied by 0 gives us a 0. Anything raised to the power of 0 gives us a 1, so we have 1 multiplied by 1, and now we have 4 plus 0 plus 1 is equal to 5. Okay, this is 5 base 10. Now this is cool, right? So we see that we were expecting to get 7 minus 2 is equal to 5, and then when we expand out our answer, we get the 5. So we know that we've done it right. Okay, so that's cool. So we're able to subtract those two particular binary numbers. But let's take an example of where we have to carry something. Okay, so if we were to take the numbers, let me just draw a little line under here. So if we were to take the numbers 27, which is 1, 1, 0, 1, 1, minus 1101. So these are the two binary numbers. So this is actually the number 27, and then this is the number 13. So when I subtract these two, I should get the number 14. Okay, and this is what I'm looking for. So let's think about those rules first of all. Okay, so well, we know that the rule, we have 0 minus 0 is going to be equal to 0. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. And 0 minus 1 is equal to 1 if we can borrow. Okay, so only if we can borrow. So now let's start applying these rules. So we have, well, 1 minus 1 here is actually equal to 0. So that's fairly straightforward. 1 minus 0 is going to be equal to 1. So 0 minus 1, well, we need to borrow. So what we do with borrowing is we take a 1 to the column from the left if we can. And if we can, then this then becomes a 0. Right, and when we take this 0 here, we scratch that out. And as we're taking 1 from the column to the left, well then this is obviously of much greater value. Right, so we have 1, 1. So now we say 1 minus 1 is a 0, but we still have another 1 left. So we say 1, 1 minus 1 is equal to 1. Now we will move up and we say 0, which is what we're left with after carrying before, or after borrowing. So we say 0 minus 1, well, we can't do that. We need to borrow again. And so we say 1, 1 minus 1 gives us a 1. And now we get the answer of 1, 1, 1, 0. Okay, and base 2. So again, when we're borrowing, right, the important thing here is to look at, well, if we can't do it, we move to the number that's to the left. We take the 1, which returns this as a 0. And then as it comes back, this becomes a 1, 1. And then we do the calculation. So it's like 1, 1 minus 1. So the two 1s cancel out, but we're still left with a 1. Okay, and the number that we get then here is 11011 minus 1101, and we get down to 1110 base 2. So let's take a little look at this. Okay, so again, if we want to do this as an expansion, so we take the number 1110, we identify the least significant digit, we write a 0, we count from right to left, 1, 2, 3, identifying the indexes, and now we simply take the number, which is 1, multiplied by the base raised to the power of its index, plus 1 multiplied by 2 to the 2, plus 1 multiplied by 2 to the 1, plus 0 multiplied by 2 to the 0. And we work this out, we have 2 to the 3, which gives me 8, multiplied by 1 is 8, plus 2 to the 2 is 4, plus 1 is going to be, 4 multiplied by 1 is 4, plus 2 to the power 1 is 2, multiplied by 1 is 2, plus 2 to the power 0, well, anything raised to the power 0 is equal to 1, multiplied by 0 gives me a 0. Now if I calculate this up, if I add them, so I say 8 plus 4 is 12, plus 2 is 14, base 10. Okay, so, and as we expected, well, I guess when you look at it, just here we would say, well, 27 minus 13 is equal to 14, and this was the calculation that we were trying to do. Okay, let's summarize this. Let's go back through a little bit. Okay, so if we go to the very start, well, we can see, well, look, what we're trying to do here is we're trying to understand this idea of binary subtraction. So just like any number system, we need to be able to subtract two different numbers. The important thing about the binary number system is, well, we're only dealing with ones and zeros. So we should be able to do any type of calculation in binary that we can do in decimal. right? But we just need to have some very simple rules. All right, so in the binary number system, so these rules are, well, we have 0 minus 0 is equal to 0, 1 minus 0 is equal to 1, 1 minus 1 is equal to 0, and 0 minus 1 is equal to 1, but only if we can borrow, right? And we need to borrow from the column that has a higher number. So now we went down, we did some examples. So we took a very simple example of 7 minus 2 is equal to 5. And then we followed these rules, and we had 7 is equal to 1, 1, 1 minus 0, 1, 0. And our answer was 1, 0, 1 base 2. We then provided the expansion to be able to see, well, how do we convert this into a decimal number? So we took the number, we multiplied by the base raised to the power of the index, and we get 5 base 2. So we show that subtracting 1, 1, 1 minus 0, 1, 0 is equal to 1, 0, 1, which turns out to be 5 base 10. Now we took a slightly more complicated example where we had 27 minus 13, so we should get 14. And this time we had to do some borrowing. And the borrowing takes place where we have, in this instance here, we started off with a 0 minus a 1, so we couldn't do it. We borrowed from the left, and then we brought back that number to be able to do the subtraction. And we ended up on 1, 1, 1, 0. To prove that this was right, we did an expansion, and we simply converted that number back into decimal, which showed, well, we actually got 1, 1, 1, 0, when we expanded out is equal to 14 base 10. Okay, so we should hopefully understand that we can do simple calculations with binary. We should understand the binary number system and how we can actually do those calculations, and then check if we're right by just simply converting back to decimal in this instance. So now that we're all done, all we have to do now is draw a little happy face. Okay, thanks.